No.
Hello everyone, we're going to show our final project towards gesture recognition on soft tactile skin. My name is Bo.
I'm Adnan.
And Muhammad.
Next. So our motivation is utilize this tactile skin to perform gesture recognition. As you can see, this tactile skin can have interesting application like this. Next. So this is the tactile skin manufacturing process. We don't go over this, but the basic procedure is that we fabricate it, we assemble it, and we calibrate it. Next. Our target is gesture recognition. So in order to perform gesture recognition, we need to accurately recognize or localize where the contact is happening. But after installation, we don't know which cell where is it. So we need to use a neural network model to localize the contact. Next. This is our fully automatic data collection procedure. We first perform surface sampling. We plan the trajectory to have the robot arm to swipe the tactile skin over the force sensor, which is fixed in space. So we have data over time that is containing the ground truth data, ground truth positioning data, plus the sensor output over time. Our sensor is a 16 by 16 sensor. Next. Yeah, go.
Okay. We run through this problem with two models, a model for a single touch and another model for multi-touch. For a single touch model, we are using a simple MLB with 4 linear layers. The input features are 256 features, and the output dimension, of course, is in the dimension of 2, which is X and Y positions. We trained this model for 300 epochs with a learning rate of 10 to the power minus 3. Our loss function was a mean square error, and we found that the best optimizer was Adam. So our final results was 1.9 e to the power minus 5 for training loss and 3.2 e to the power minus 5 for testing loss. Next. So here is a visualization of our result. We have the true position. We have on the right side, we have the true position versus the regressed position. That's the output of our MLB. You can see that the points are pretty close together, and we actually can reach a better result by tuning our model. Next.
Then comes our multi-touch model. We combine 2 single-touch sequences to generate the data set, and we approach this via a convolutional neural network along with max pooling and linear layers. We trained for 175 epochs, and we used the same information learning rate loss function optimizer from our single-touch model. The unique thing we added here was anchors, where the centroids are incorporated in the loss function. And our final results were that we achieved 89.1874 for training and 94.9838 for testing. This is the architecture. We start off with convolutions, then drop out linear and ReLU. And the linear output at the end is used to compute confidence, and ReLU at the end is used to compute the offset. And then here's the result. There's triple pairs in each frame here. And you can see that the regressed output and the ground truth are almost identical. Then we have our gesture recognition model. We approach this via the long short-term memory model, and then linear, ReLU, and softmax as well. Input dimension were the coordinates, X and Y, and output dimension was the class, none up and down. Epochs were 40, and our training loss was 1.057938, and our test loss was 0.5514. So I'll quickly go over the demonstration. So Bo is going to touch 2 points, and then on the video you can see that wherever he touched on the sensor matched. And then we can show the multi-touch as well. Same as before. You'll touch 2 points and it will show the reading just accurately. And then with the gesture model, we didn't achieve much success here. Bo rolls his hand, but the reading is not accurate here, so we still need to tune this model.
So in our work, we run through multiple experiments, and most of them was failing experiments. However, we're gonna report them. So in multi-touch, we try to predict the end position tuples directly, without using the CNN layers. So this didn't work actually. Also, we tried classifying the number of touches and position tuples separately, but also it didn't help. We also performed discrete cosine transform on the time series data for each cell, but also it didn't help. Our last failing experiment was using Fourier features, like what we did in our mini project, but also it didn't help well. So in conclusion, we can conclude our project with these points. LSTMs with MLPs works with single touch prediction, but not multi-touch. Convolution layers are with anchors are significantly improving our multi-touch models. We synthesized some superposition on skill response for multi-touch, and this actually could work up to two touches in real life. For synthesized data, it could work with 3 touches. And our dataset for gesture recognition is too small, actually, since it's difficult to produce such data. However, we predict that we could get pretty good results if we have larger dataset. And thank you everyone for listening to us.
Thank you.
Thank you.